slope-intercept form. And I guess the little subtitle, this is all one big thing. This is linear equations. Now all this is going to take a really long time to discuss because we have to define some things. First of all, what do you suppose a linear equation is? You being the linguist you are. If you break apart the two words linear and equation, anybody? I hate to state the completely blindly obvious. If I break it down into syllables, linear equations. Zachary, what do you suppose linear equation means? Equations that make lines. Now, if you go back, really, you can see we did one over there. That thing right there that we did for problem whatever that somebody asked me to do and I said we would do today. What problem was that?
14.
Problem number 14. Number 14 had that y equals 4/5 x minus 2. That's a linear equation. For the simple reason is this. There are two different variables here, and because there's two different variables, there's an endless amount of answers. A little bit like this. Let me see if I can explain it this way. Let's say Caleb Fisher gets a job. Caleb, where do you want to work? McDonald's is a good place. Why not? Caleb gets his job working at Mickey D's, and he makes $8 an hour. How much does Caleb make per week? Whoa, somebody said something. What did you say? It depends on what he works. Okay? And this wage could be described like this. Okay? The money he makes, we'll call Y, equals 8 times X. What do you suppose X is? X is how many hours, and Y is how much cash he's going to make. There is no one answer to this because it depends on how many hours he works in a week. And that's where we do this. We make ourselves a little table. Well, if Caleb works 0 hours, he's going to make how much money? $0. Let's say he works for 1 hour and he makes $8. If he works for 3 hours, he's going to make 24 hours, and that's where our little graph comes from because we make these rectangular coordinate ordered pairs and we graph it. 0 hours, $0. 1 hour, 1, 2, 3, 4, 5, 6, 7, $8. 2 hours, $16. This line, that line we get from this linear equation is all the possible answers we can get for Caleb. If Caleb works half an hour, guess what? He's going to make $4. If he makes 1.5 hours, he's going to make $12. That falls right there. Got that? So sometimes we don't have exact answers, but we have multiple answers, and the only way to show that is through a line and a linear equation. So that is a linear equation. How about that? Halfway home, kids. Now we have different forms of linear equation, and today we talk about this one, the slope-intercept form. Slope-intercept form, to which you're going to say,
what is the slope?
not what is but what is the.
What is the intercept?
Alright, this is, remember, usually in every lesson I have you draw something really big. This is your really big thing for today. That's just an equation that won't make any sense to you, but it is what it is. you need to write this down. Y equals mx plus b. Write that down and decorate it because that is the most important thing to remember from today. Because I know you were fascinated at the point, did you ever sit there and go, you know, I graphed this equation like really fast. I didn't have to sit there and do a whole table and do stuff. Did you ever were you in awe of that for at least a little bit? Pausing, did you look at it and go, how did that work or whatever?
Yes.
Don't have it. You can do that because of this. And this is what these letters mean. This is the generic form of it. You can't graph a line that looks like this. There have to be numbers that are inserted for the letter B and for the letter M. Okay? There have to be numbers there. And the book will tell you those numbers. The letter B is what we call, this is what we call the Y-intercept. What do you suppose the Y-intercept really means in 7th grade words, Sophia? What does the word intercept mean? Crossing. This is where the line crosses the y-axis. Whatever is in the place of the letter B is where the line crosses the y-axis. Point over here to Mr. Board. This was my equation. This is what my letter B was. And that's where I came up with this. It crossed, this is the y-axis. It crossed the y-axis at -2. So I just put that point there because you can put that point there because that's the y-intercept. Okay? The letter M, children, is what we call, M is the slope of the line. And we've talked slope before, have we not?
Yes.
What does slope mean? Slope is, oh boy, we've talked about it, but nobody remembers. Anybody tell me, my kingdom for somebody who can tell me what slope actually is? Joseph?
The pitch.
It is the pitch, but more 7th grade terms. It is the slant, but more 7th grade terms, more practical applications. Anybody, slope is? Madison?
How tall no, that's not it.
Thank you, Caleb Fisher, for looking back in your notes on slope. What is slope? Grace?
From left to right.
Yes, it is go from left to right, but it is specifically what? How do you know what slope is? Fish?
Slope is from left to right. It's like the rise /
Rise
And fall.
over
Run.
run. Or, more practically, how high something is over how wide it is. Which means this. Go back to this line that I graphed over here. My slope here was 4/5. That means it goes up 4 for every 5 it goes over. So, just don't hum me until I'm done explaining.
I thought you were done.
Okay? See, I started off with this point because I know for sure that's a point on my line, because it's the y-intercept. From that point, I went up 4, 1, 2, 3, 4, and I went over 5, 1, 2, 3, 4, 5. And I know that has to be a point because it makes the triangle that I need, and that triangle is 4 high for every 5 wide it is. That makes it its slope. I only need 2 points to make a line, so that's what I get there. We've done slope before, haven't we?
Yeah.
Did we have to figure out slope? We did
Yeah.
figure out slope. We used a triangle to figure out slope, did we not? Madison?
Well, why did you choose the number 2? Like, how would you know?
I didn't choose the number 2, I was given the number 2. This 2? This 2 is the equation that was given to me.
But how would you know where to put it on the board? Because normally you would go, oh, it's negative.
I knew because this is my letter B and it crosses the y-axis at that point. Here, let me give you another one. Take a look here. Here's another example. Let's say y equals 1/3 x plus 3. The first thing you start off with is, I gotta recalibrate this thing. First thing you do is you plot, which means put a point at the y-intercept, which is right here. This is my y-intercept. That means on my graph, I'm going to start off with a point where? +3 on the y-axis. So here's my y-axis. I go up 1, 2, 3. This is probably a good time for me to tell you, you won't be guessing like I am, because on your homework paper, there's all sorts of squares to make grids out of. You're not just blindly putting them anywhere. Stop me if you didn't get that guess, Connor Moore.
So you're showing us like the thing that literally just letters? Will that happen in your graph?
No.
Okay.
The generic thing I gave you, this y equals mxb, is what we call the generic form of it. You can't graph this because there's no numbers there. But you will be given the number for the slope, and you'll be given the number for the letter b, and you'll have to make a graph out of that. But this is the generic form of it, where you can put, it's just like the formula for area of a triangle is 1/2 base times height. That doesn't tell you anything, it's just you have to put the numbers into it to figure it out. Well, this is the thing that you have to put the numbers in, or they give the number to figure out. So once you have that, children, step number 2 is you take the slope, use the slope, which is in front of the x, the fraction in front of the x, and find your second point. Find point number 2 by going up the denominator, up the numerator, and over the denominator. See if you can catch on to that. Zachary, you still with me? How can you not read that? You're supposed to have glasses?
Fine.
You have glasses, Zachary?
No.
Huh? You've never had them?
No.
You're supposed to wear them?
No.
Really? Is it just me? Okay, so that means this. What? Denominator. Denominator. Up the numerator, over the denominator. Okay, so I start with this one point that came from my y-intercept. Now from that one point, I go up this many. Okay, so I go up 1. That's not a point on the line yet. That's just how far I go up. And then I go over 3. Up 1, over 3. So bam. And there's my second dot. To which you might ask, and that's why Andrew is raising his hand, how do I know whether to go over 3 that way or over 3 this way? Because either way it's over 3. How do I know which of those I use? Because realistically, both of them are possibilities. Sophia?
Well, if it's positive, you want to go up and to the right, and if it's negative, you want to go down.
Correct. Because this slope was positive, my little line has to go uphill from left to right. So I have to use this one, otherwise it's negative slope. So bam, there's my line. And what that line is every possible answer that you could get from this equation. It goes on forever in both directions. Math.
How would you know if the top number of the fraction is positive or negative? Would there be a negative
It
sign?
doesn't matter. If there's a negative sign in front of it, it doesn't make any difference.
Then how-
Here, let's do one. Y equals negative, how about this? Negative 5x minus 1. See if that throws people for a loop. If you follow our clear, concise, and simple directions, by the way, you should be able to get to the first step very easily. What's my first step? Where am I going to put a point? Where am I going to put a point, Caleb Fisher?
At the negative.
Where? On what negative 1? Because here's a negative 1 and there's a negative 1.
The one on the Y.
It's the y-axis. So on the y-axis, negative 1. Tell Julie to check her email. Email her a dozen times. Alright, now, here's where people are going to get all in a tizzy. Oh no, there's no fraction in front of the x. Well, yes there is, Lauren, because the fraction is, yeah, you make it a fraction by putting 5 over 1. Okay, now it doesn't matter, Madison, this was your question. What if this negative thing, it doesn't matter if this negative is by the 5, by the 1, or sitting out in front here. The whole thing's negative. That just tells you your line is going to go downhill. So it don't matter. You are going to go up 5, 1, 2, 3, 4, 5, and over 1. Well, your choice is to go over 1 this way or to go over 1 this way, but there's only one way that you're going downhill, and that's to pick this over 1. So your line is going to be this
Okay.
right there.
Please, please,
Connor Morgan.
if it's negative, then why don't you go down?
You can. Connor made a good point. Here, Connor, look. It not matter. I still have my negative 1 right here, right? Well, I'm going to go down 5. 1, 2, 3, 4, 5, and over 1. Except which over 1 do I got to pick? The over 1 that goes makes it go downhill. It has to go this way. This line and that line are the same line. I just missed it. We will continue said discussion.